Welcome to the basics of counting. You've seen applications before in our development of your computer science or background, either major or minor. You've seen some of these problems before, but there's actually a bunch of different rules. We're going to see a product rule, subtraction rule, addition rule, and division rule that, well, we need to make sure that you're accomplishing covering all the possibilities that we can for a particular application. In a product rule, and I'm going to have three examples, and then the last example has a tree diagram, which frankly will make a lot more sense visually than it will with all the stuff that we're doing here. This is basically a procedure that can be broken down into a sequence of at least two tasks. There's one way of doing it. End of the one is doing the first task, then you have end of the two, so the second task, and therefore, and so on down. And then you can do n to the x ways to do the procedure. They're going to be multiplied together because, again, you can think of permutations and combinations here, just like this very simple problem for right now, and then we'll get into a little harder ones here. How many bits of string of length 7 are there? Now, notice it says bits, which is really important. It's going to be, we have two options of 0 and 1. We're also given 7 letters, so there should be 7 boxes here, if I didn't screw something up here. So how's that going to work out? Well, we're going to have 2 options for the first one, 2 options for the second one, and then all the way down, and that really is base 2 to the 7th power. And again, if I really wanted to put the equation behind it, I could do my end of the 1, end of the 2 for each one of them, and they would happen to be the same. By the way, in this particular problem, they all happen to be base 2 because that's our choices. There's only 2 choices that we have of 0 and 1. Once we start manipulating this example number 1, think of it kind of like your your ID, or maybe your Social Security or something of that nature, where there might be a little bit more, well, to it. Let's just put it that way. So this is just an really simple problem. So as you know, it's going to end up being 2 to the 7th equals 128 possibilities that we have for a bit string of length 7. But the next couple examples obviously get a little bit more interesting. And here's one that does a mix. We have different license plates can be made of each plate containing a sequence of 3 uppercase English letters followed by 3 digits. So notice, by the way, I'm trying to be as visual. You know I'm a visual person here. I'm trying to visualize this thing out. This is going to be total length of 6. The first 3 options, there's 26 choices. Now remember, I'm being very specific here on uppercase English letters. So that's why 26. And then followed by 3 digits, which is from 0 to 9, which is 10 choices for each of them. So notice that's going to map to exactly what I have down here. But notice the multiplication again, because I want my different options. And you know that from other classes you've had before. So the first 3 are going to be times 26. The last 3 are going to be multiples of 10. So we have 26 to the third, grouping the first 3. And then we have 10 to the third, grouping the last. Again, notice in the equation-wise, there's our different n's that we would be spelling out. But again, the n's don't have to be the same count. There's 10s and 26 on this one. Using the product rule, here's the product rule. We're multiplying all of this out to basically get our different possibilities for license plates. And what's that, 17.5 million, something around there? Just multiplying the 2 items together. That's it. Pretty simple. Here's where things get a little bit more interesting because, notice again, I'm a visual guy, but honestly, I'm not sure how you'd be able to do this without doing it visually, and that's introducing the tree design. In this one, what I'm going to have is I Love Computer Science t-shirts come in 5 different sizes. A small, a medium, a large, an extra large, and a large. Now, by the way, I'll be honest, I wasn't reading here, I was reading here. But anyway. Each size comes in 4 colors, red, white, green, and black. So you see the 4, they're all coming. White, red, green, and black. Yep, okay, right, all 4 of them, okay. Except extra large must come in red, green, and black. Yeah, I was going to say blue. An extra large, which comes only in green and black. Now you know why I went ahead and designed this all out. Now you know why. What is the minimum number of t-shirts the campus bookstore needs to stock to have one of these size and colors available? Draw the T diagram. Notice drawing this out made this a heck of a lot easier. So it's going to be at least 17 t-shirts that it needs, and it's being highlighted right now. That count should be 17. So having the tree diagram really helps things out. You may not always need it. To be honest with you, the first two examples, you didn't need it. But you're doing this one. Notice how some of them have an exception. That's where the tree diagram really comes into play so that you can kind of map it out and get some type of feel for exactly what the overall count and combination is going to be. It's on your own this time. By the way, the book has like 3 or 5 other different examples here. The chapter in Rosen, the book that we're using, literally is 10 pages for this entire chapter. So there are other examples I would like you to take a look at in the book. They're not very large except for one. There is one massive one that frankly, but anyway. Go ahead and start working on this problem that we have down below here. It's going to take a break, take a look at it, get it done, and we'll go over here in a little bit.